Welcome to becomeatechpro.com. This is the introductory session for the DevOps class of November 2022. In this session, I will try as much as possible to answer most of the popular questions that have been coming my way. And the questions include, what is DevOps? Why are organizations embracing the DevOps methodology? What makes the DevOps professional highly sought after? Who can become a DevOps professional? And also, are there many DevOps jobs out there? These are very, very important questions that have been coming my way. And as much as possible, we should be able to have answers to these questions at the end of this session. Firstly, let me narrate a story. This story will give us an understanding of what the DevOps methodology entails. Now, in this story, I have two major actors, right? And there are two teams, basically. There's a team one and there's a team two, right? Team one is the development team, right? And team two is the operations team. Now, the development team comprises the developers, right? And the operations team comprises product managers, right? People within the IT operations of the organization. Now, the product managers tell the developers what they want, right? In terms of the expectations, what the clients, the features they want for a particular software development. And the development team, in their own right, go ahead and build the application to the specification of the operations team, that's product managers, right? Now, and after building this within their environment, they tested it and everything worked well. Now, they deliver it to the operations team. And the operations team tested it out within their own environments and it failed. Now, what do you think could have happened between the two tests? The only thing that is different is the environment. One tested it in an environment and the other tested it in a different environment. So that is just the difference. Now, from this story, I'm going to move you to a different story, familiar story, maybe something you would have been used to. Now, let's say you decide to embark on an agric project in school or wherever. Let's say you embark on an agric project and you were able to bring a seed, right, under the supervision of the teacher. We're able to plant a seed, nurture it for a while, and it grew in school, right? Within the school environment. It grew using the pot that was given to you. So after a while, you took this home and gifted it to your sibling. And your sibling takes the plant out of the pot and transplanted it into the soil and was watering it accordingly. But unfortunately, after 3 days, the plant was withering, right? It was almost dying. Now, what do you think could have happened? Obviously, when it was planted and nurtured, it was planted in a loamy soil. But what I think would have happened would be the sibling took the plant and put it in a sandy soil, or any other thing could have happened, but it didn't survive. So what will make that plant survive? A professional eye needs to come in, somebody that understands plants and soil, to be able to say, oh, you don't need to plant it in a sandy soil, you need to move it to a loamy soil. Okay, so, and if that is done, you see the plants will grow and flourish. Now, back to my initial story. The developer, the operations team, they both got it right, in terms of testing and all of that, in terms of production and testing. But unfortunately, something is missing. Somebody is missing from the equation. Somebody that understands the language of both parties. That's the developers and the operations, right? We will say, oh, you need to move the plant from the sandy soil to a loamy soil for it to work. So also within the software development process, you need the DevOps engineer, somebody that understands both languages, who will be able to bridge the gap, right? The gap between the development team and the operations team. So that is the DevOps professional for you. That is where he or she comes in, right? So now, enough of stories, right? So let's look at the popular models used in the software development lifecycle. Okay, so let's see popular models using software development lifecycle. So you might have heard about the waterfall model. The waterfall model. Right? So the waterfall model. So under the waterfall model, there are key phases, right, in the software development lifecycle. And these key phases include the requirement gathering phase. That's number. The requirement gathering phase. Right? The requirement gathering phase. What happens at this phase? At this phase, the technical leads and the solution architects, depending, will meet the clients to understand the requirements. Okay? They will meet the clients to understand the requirements at this stage. That's the technical leads to meet the clients, to discuss requirements. Right? For example, if an organization wants to develop a software, they need to have a conversation with the developers, right? So members of the development team, right, the technical lead or the solution architect, we meet with the client to discuss the specific requirements they need in the application to be built, okay? So now we can look at a second stage. The second stage will entail design, right? Design phase. So what happens at the design phase? The technical leads or the solution architects will document all the requirements, right? They've met with the client. The client has told them what they want to achieve. Now, they need to now document all these requirements, right? They are back at their offices. So they need to document all the requirements and specifications, like high-level documentation, and specify their system requirements. So technical leads to document the requirements and the requirements and all specifications, including system specifications. Specifications, okay. Specifications, okay. And all specifications. So this is a very important stage because it's at this point that the technical leads will say, oh, like the roadmap in terms of what should get done, like interpreting what the client has said. So they document it. So after documenting it, we talk about implementation. So after documentation, we have the implementation phase. Okay? So under this phase, the developers will write codes, right? Under this stage, developers will write codes to write codes under the stage. That's when the developers will write the codes, the unit test cases, and the build scripts. So under that stage, that's what happens, right? Now, after this is done, we have the testing phase. The codes have been written and everything seems to be going right, well, as planned. So we now get to the testing phase. Testing phase. Under this phase, the QA, right? QA or the testing team. Testing team will now carry out all the necessary tests to ensure that the development is in line with the requirements. Because remember, at the design phase, there's a documentation that has been done, documentation of requirements and all system specifications. Now, at the implementation phase, we see the developers writing codes and making sure everything is done to those requirements and specifications. Now, after that is done, the testing phase, we now see the QA and the testing team carrying out tests to carry out tests to ensure that the requirements are met, that the codes that have been written, the test cases and the build scripts are in line with the requirements. Development is in line with requirements. With requirements. Okay? Development is in line with requirements. Okay? So after this stage, what happens? Now we are looking at the deployment stage, right? The deployment stage. So who is the player? Who are the players here? Talking about the middleware admin. Okay? Middleware administrators. Deployment phase. So here, the middleware admin will deploy. They will release the product to the market. Middleware where admin to release the products to the market. Okay, so the middleware admin will release the products to the market. So that's what happens at this stage. So after this stage, we now talk about the maintenance phase. Maintenance phase, okay? Maintenance phase. So now at this level, there'll be this support team that has been set up to assist with resolving issues that come up post deployment. Now, the product is in the market, it's been released to the market. In the course of use, there'll be feedback on certain functionalities not working well enough or certain functionalities requiring improvement and all of that. So at this stage, at the maintenance phase, the support team will assist in resolving issues, right? The support team will spring to action in resolving issues that come up, right? So this is the waterfall model. We have the requirement gathering phase, we have the design phase, we have the implementation phase, the testing phase, the deployment phase, and the maintenance phase. Now it looks good, right? But it has some shortcomings, right? It has some shortcomings. So some of the shortcomings include poor utilization of human resource. Now, if you look at this, if you look at between stage one, phase one, and phase two, the timeline between these phases could be long, maybe 2 weeks, 3 weeks, 4 weeks, depending, right? Especially the design phase. By the time this guy gets back to the office, try to design, right? And document the requirements and specifications, right? So at phase one and phase two, you notice that it's just the technical lead, right? And the solution architects that are working, right? Then implementation phase, the developers spring to action, right? Then afterwards, the QA and testing team spring to action. Then middleware admin to release products in deployment phase before the support team will come on board, right? After deployment, post-deployment, right? So now, if you look at it, you notice that there's poor utilization of human resources, because at some point, the developers will be idle, the testing team will be idle, middleware admin will be idle, and the cycle keeps going, right? So you see there's poor utilization of resources, poor utilization of resources. Now, also, if you look at it, you notice that the time to deliver is so long, right? Because it takes time for all these things to get done, right? So, and the major disappointing shortcoming is that clients won't know whether there's a problem or not until the product is released. And aside that, in the course of waiting, the clients could have even moved on, right? In terms of ideas and requirements, or things have happened in the market and they want a change, right? So these shortcomings will lead us to the adoption of the agile methodology. Agile methodology. Okay, so now let's look at the agile methodology. The agile methodology. So let's look at the agile methodology. Now, the agile methodology is based on the Scrum model. It may also be based on Kanban. Okay, so we'll discuss these two models. Okay, the Scrum model or the Kanban. So that is what agile methodology is based on. Okay, so agile methodology. So looking at agile methodology from the point of view of the Scrum model. Okay, so Scrum model, Scrum could be based on Scrum model or Kanban. 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 Okay. Okay. So Scrum model or Kanban. So let's take it one at a time. Okay. So the Scrum model is based on sprints and the amount of work to be undertaken will depend on team velocity. So we've mentioned two terminologies, right? Sprints. And number two, we've talked about team velocity. So sprint and team velocity. So that is what the Scrum model is based on. So now let's take it one at a time. So if we look at sprints, sprints are short timelines that a Scrum team works to complete a specific amount of work within a project. Let's say there's a project to complete certain application development, right? Now, this will be divided into several sprints, like, oh, within this application, we need to complete the login module, the database module, this module, that module, right? So all these different modules, right, to be completed will be split into different sprints, right? So you see, all these different tasks are within the project. So these different tasks will be divided into sprints. And sprints could be as long as you may want it, but usually it is between 1 week and 4 weeks. However, the standard being set for most organizations is 2 weeks. Okay. Now, so for every 2 weeks, for example, if we are going by the standard, for every 2 weeks, you have a sprint. Every 2 weeks, make one sprint. So what is expected to happen within the sprint is that those tasks, right? Those tasks that have been assigned to happen within the sprint is expected to be completed. So you're not waiting for maybe 1 year to complete the entire project before the client now sees what is happening, or whether to provide feedback on all of that. The client does not have to wait for 1 year, but in 2 weeks, they can get something, right? And provide their feedback, and work continues, moving to the next sprint. Okay. So I also mentioned team velocity, right? So sprint, maybe let's say timeline, short timeline, let me put a note, timeline to complete specific tasks within a project. Short timelines to specific tasks within a project. Now, we also talked about team velocity. So team velocity is the measure of the amount of work a team can take within a single sprint. Okay, so team velocity now is dependent on the number of manpower available for the sprint. Okay, so that is team velocity. Okay, so is the measure of the amount of work which will be determined by the number of manpower available within a single sprint. Okay, so now that's team velocity, the measure of work that can be undertaken within a sprint. And this is determined by the available manpower. Okay, so that's that. Manpower. Okay. Okay, so that's that. So now let's see how sprint tasks are arranged, right? Because there's a Scrum board within the organization, right? The Scrum board within the organization, which can be divided into 3 or more columns, right? So on the job board, on the Scrum board, we have something like Scrum boards will have columns, which could be 3 or more, indicating some components. Okay, so Scrum board will have something like this, which will comprise, let's put a column. Okay, the Scrum board will have something like to do, right? You know, we have a sprint and everything has to be organized, right? Because it's agile, right? Everybody's up to speed, right? Agile. So it will have something like to do. It will have something like in progress. those will be the typical columns on the Scrum board, and it will have something like, let's say, completed. Let's see if we can see typical Scrum board. Let's see, Scrum board. Okay. Let's see images. You can see this one has, that was an interesting image. You can see this is a typical Scrum board. It indicates it has how many columns, right? So this is the story. That's like the task to be, what that sprint encompasses, right? You have to do, you can see to do, doing, right? Doing, this like in progress. Let's see if we can expand the image. Okay. Backlog. These are the backlogs. This is story, to do, right? Doing, in progress, done, completed. So the wording could be anyhow, right? So it could be, like this. For us, we have in progress, there's doing, completed here, shows done over there, you see? So that's a typical Scrum board. So also, let's look at this. Okay, before we go to Kanban, there are some important things we should also be able to look at, right? Some major features of the Scrum model. You see, the Scrum model is characterized by Scrum meetings, right? At the Scrum meetings, several updates are provided. So let's look at some examples of Scrum meetings that we may have, right? There's a sprint planning meeting, okay? There's a sprint planning meeting. Let's sample Scrum meetings. Okay. Let's see, sample Scrum meetings. Scrum meetings. So we have the sprint planning meeting. Let's put them. Sprint planning meeting. We have the daily stand-up meeting. Daily stand-up meeting. You have the sprint review meeting. Sprint review meeting. Sprint review meeting. Review meeting. You have the sprint retrospective meeting. Sprint retrospective meeting. And we have the product backlog refinement meeting. Product backlog. Refinement meeting. Okay, we have the product backlog refinement meeting. Okay, now let's look at these meetings. You see, this first and the third meetings are usually held with both internal and external stakeholders, right? At the sprint planning meeting, we have the members of the Scrum team, right, alongside other stakeholders like the product manager coming to say the expectations of the products and all of that so that everybody can be on the same page, okay? And the meeting could be as long as 2 hours because this is a meeting that will provide details, right? To provide details of what should be done and how things should be achieved, right? It's a detailed meeting. Then on a daily basis, there's a short meeting, which is the daily stand-up meeting, where everybody can provide details on what they have done and what they will do and mention the challenges they faced, right? So that if need be, they can get the necessary support to keep the targets set achievable, okay? Now, we have the sprint review meeting. Now, this sprint review meeting is done at the end of the sprint such that we can have the external stakeholder being present and the output is delivered, right, to the client, and they're able to discuss and overall, right, what was achieved during the sprint, the 2 weeks or 3 weeks or 4 weeks, depending on the timeline of the sprint, okay? So they're able to deliver on what has been achieved. Now, the sprint retrospective meeting will not have the external stakeholders, right? So now have the external stakeholders at the retrospective meeting. We'll have just the internal stakeholders discussing what could have been done better during the sprint and all of that, right? Because this is what is internal, right? So they'll discuss that to have an improvement as they move into the next sprint, right? Because it's ongoing, everybody's involved. In 2 weeks, something has been delivered, right? You see, this is different from the waterfall model where nothing much, right, was delivered. Okay, now, then the product backlog refinement meeting, right, is not something that happens all the time, but at this meeting, all the backlogs and improvements are discussed, and it is not something that happens during every sprint, right? So this is just a meeting that happens once in a while. Okay, so now remember, we also said it could be sprints, it could be agile methodology, could be based on the Scrum model or the Kanban model, right? So the Kanban model is very similar to the Scrum model, right? In terms of the use of boards to organize work. But the only difference is that it does not set time limits, right? Like here, where we have sprints of 2 weeks, or so there are no time limits set, but as much as possible, it is so organized and so efficient with the use of boards such that you are up to speed in achieving the set objective. So that is Kanban model for you. So Kanban, similar to Scrum, but doesn't set time limits. Okay, so, but doesn't set time limits. Scrum with the use of boards. Okay, so that's that. So that's Kanban for you. Now, looking at all of this, right, and taking a short flashback to the story I said at the beginning about job being done at a certain environment and delivered and not satisfactory, right, led to the introduction of the DevOps methodology. So let's look at the DevOps methodology. Okay, so that's the DevOps methodology. Okay, so you see, based on the story, see how important the DevOps methodology is. Okay, so now, what is DevOps? DevOps refers to the methodology. It is a methodology, okay? Methodology and strategy used to introduce automation, right, into an environment to ensure that the project or the application or the software is delivered efficiently and effectively, okay? So to achieve this, okay, to achieve this, there are certain tools that we need to be used, right? There are certain DevOps tools that need to be used to be able to implement the DevOps methodology, right? So, and the stakeholders will include the product managers who will tell us what they expect to achieve, the developers, the guys that will write the codes and unit test cases and build scripts. Now, the DevOps professionals who will use the tools to ensure that a balance is struck and everything is working well. They will need the QA managers in the environment as well, then the support team and the incident management team. So those are the people who need in the environment. So there are several tools that I'll be looking at, and so let's take a look at the model, right? The DevOps methodology. We've mentioned it that we'll be using several tools to ensure efficiency and effectiveness in delivering applications or projects, right? So let's take a look at a typical environment. So let's say we have, okay, let's look at a monolithic application architecture. Okay, so before we proceed, let's discuss and understand what a monolithic application architecture is. Okay, so for example, you have a website, right, that has the login components, that has several other components, right? The login, the order management, and several other components, right? Now, when all these components are put together and deployed as a single application, right? The login, user management, reports, admin, everything is commingled and deployed as a single application, such that you cannot readily separate them, right? Then you are talking about having a monolithic application architecture. Mono means one, single, everything is bundled, right? Let's look at the website, for example. Let's say, let's look at, okay, let's look at this. Okay, so if you look at this, for example, you can see the login, right? You can see my orders, right? You can see the user area, you can see subscription, you can see several components, you can see where the stores are, right? You can see different components, right? So all these components, when they are bundled together, right, and deployed as a single application or package, it is called monolithic application architecture. Whereas in a situation where you choose to take care of my orders separately, my subscriptions separately, right, my account separately, and the different stores, right, different components, you take them as separate components, as separate applications. Then you talk about the microservice architecture. And in that case, you are using containers to deploy those applications. And you're talking about things like Kubernetes, talking about Docker, right? So when you start to deploy using deploying different modules, right, as separate applications, right, as we have here, then you are looking at the microservices application architecture. Microservices, microservices, not just one. The other one is mono one, right? Okay, so now let's look at the diagram that we have here. So under a monolithic application architecture, okay, so I want you to follow the numbers, right? I did some numberings. It will guide us, okay? Did some numberings, okay? So these numberings will guide us, okay? Don't get us confused because these are so many things put together, okay? Now, in a typical setting, what happens? The developer will commit their codes, right? These codes, the unit test cases, the source codes, and the build scripts, right? They will commit them to a source code manager, right? A source code manager, maybe it could be GitHub, it could be Bitbucket, it could be GitLab, it could be Bitbucket, right? So these are source code managers, right? So the developers will commit their codes to this place, okay? Now, so many things will happen, right? And we say the DevOps professionals, right, do things in line with DevOps methodology and strategy to introduce automation to the environment, okay? Now, this is the automation tool, right, that has been introduced into the environment, right? An example is Jenkins, right? It could be Bamboo, right? So depending on the environment you are working in, right? So this is what you have there, okay? So this is the continuous integration and continuous deployment tool, right? The CI/CD tool. So this is the automation tool, right? Remember, said introduce the automation into the environment. That's what DevOps methodology is all about, right? So now this comes in, okay? So with this, the codes are pulled from the source code managers, right? Maybe GitHub, depending on which you have in your environment, okay? So code is pulled into this automation tool, right? You can see after one, we've done two. So where is three, okay? So now, here, once you have the code, right? Let's say we are using a Java-based application, okay? We're using a Java-based application, right? So we could be using Maven or Ant, right? To do a build, okay? So now the codes that have been written, right? The codes that have been written, that's not the complete application, right? There needs to be a build done, okay? So there's a tool with which a build will be done, right? So, and that tool could be any tool depending on the application, right, that is being developed, okay? For a Java-based application, we could use Maven as a tool, right? So if it's a Node.js application, we can use the Node package manager, right? So that's a build tool. So what we do with Jenkins, remember, is automation, right? We integrate with the CI/CD tool, which is maybe Jenkins or Bamboo, right? And we do a build, right? That's the third step. You know, you commit, developers commit codes, you know, you integrate Jenkins with the source code manager so that you can do your code pool, right? You could set up webhooks so that at every point in time when there's a change in the source code manager, it's automatically pulled here without manual interaction, right? So we do an integration and build, right? Because you are trying to automate the whole process. So you integrate Maven or NPM with Jenkins so that the build is automated. Because within Jenkins, there will be a pipeline script written so that all the processes will get done, okay? So there'll be a pipeline within here, right? Which is used to configure the whole processes, okay? Now, a build will be done, right? So once this build is done, we could go ahead and back it up to our Artifactory, which is maybe it could be Nexus, it could be JFrog, right? But there's a step we should also consider, right? You know, the developers committed their codes to GitHub, right? Or Bitbucket or GitLab, right? And, you know, there are requirements, right? So for these requirements to be met, there are certain tests that needs to be carried out to check the quality of the code, right? So we could do a code quality analysis using a code quality analysis tool like SonarQube, right? We could use SonarQube as a tool for code quality analysis. This does not affect this, but what it does is, if for any reason, the code does not meet up with the set standard, there will be a communication with the developers to say, hi, developers, there are some shortcomings. We are missing some targets and all of that. So please work on this, right? And they can commit further codes here. And remember, we've automated the whole process by setting up webhooks or certain triggers, right? Which will come here again, right? Which will do a pull, a code pull, right? Automatically. Okay. Now, after this step, look at this, right? We can back up our artifacts, right? What we've built, right? To ensure it helps with disaster management, right? To ensure that we do not have a major setback, right? In case something goes wrong, we can have backups, right? So we can have it here, have it backed up. Now, once that is done, you want to integrate, want to deploy, right? Want to deploy the application, right? Accordingly. So if we are using a Java-based application, right? And we are deploying a web application, for example, we can use Tomcat, right? And this web application could be static, it could be dynamic, right? So usually we want to deploy a dynamic application to Tomcat, because if it were static, you could just deploy it directly to the web server, right? Maybe in Nginx, or depending, it could be HTTPD, it could be HA proxy, right? So if it is an enterprise application, right? A web application we can deploy to maybe Tomcat or JBoss. But if it's enterprise application, we can't deploy it to Tomcat. It has to be JBoss, right? So let's take note of that. Okay, now, so looking at what we have here and here, right? You notice that we have our application deployed in here. Then we are having it move to the web servers. So why do we have this arrangement? If you look at it critically, you see that we have users here. These users are trying to access the application, right? But for security reasons, we will not allow the users to access the application directly on the application server. Rather, we'll let them access it through the web servers, right? The web servers will typically be in a public server, right? A public server, right? Server within the public subnet, okay? And we'll have this in the private server, okay? So that's for security, extra layer of security, so that whatever we have in here is protected, okay, from hackers and any form of attack. Okay, now you see, after this stage, I didn't say anything about this, right? I didn't indicate what happened there, because the whole process goes this way. However, I just deliberately included this so that we can see what is actually happening as users are trying to access. They are not accessing the application directly, rather they're accessing it through the web servers. Okay, looking at 7, right? Users are accessing applications, right? We also want to be able to set up monitoring tools to monitor the web servers and the application servers, just to ensure that everything is working well, right? So this way, if the users are unable to connect, right, are unable to connect as the way they should be connecting, maybe something is going wrong or server is down or something, with the application monitoring tools, we are able to ascertain that, right? We are able to see what the users are seeing. The users are trying to access. Also, the monitoring tools are also trying to access, right? To see what's happening. So once this is done, we need to be able to use log analysis tools, right? To analyze the logs, to see what is really happening, right? And all of this we can do maybe with Nagios, Graylog, or the ELK stack, right? The Elastic Search, the Logstash, and Kibana. That makes up the ELK stack, okay? So we analyze the logs and the networks, right? So once we get that, we can use ticketing tools to obtain feedback, right? To obtain feedback. And once we get feedback that requires action, it is redirected to the developers for further input. So this is a typical monolithic application architecture, which we explained earlier, right? So that's a monolithic application architecture, okay? So now that's that. So we can also look at the microservices application architecture, and let's see how it is different, right? So there are some things that will be common, right? Under this setting as well, the developers will write their codes and commit the codes to the source code manager, right? The same thing we've done, okay? So, and we use the CI/CD tool, Jenkins, it could be Bamboo, right? So we use the CI/CD tools to pull the code, okay? So once we pull the code, we do a build, right? Because we are using Jenkins, so we are doing integration with another tool, right? Coming in as plugin, right? And doing a build, right? So after doing the build, we can also do a code quality analysis, right? Using maybe SonarQube, okay? So after this step, we now bring in Docker into the equation. If you remember, there was no Docker in this equation we had here. There was no Docker. So here, we are bringing in Docker into the environment. So with Docker, we are able to containerize our applications. Remember, microservices, right? So with microservices, we are using small containers to put our applications in them, okay? So once you put your applications, build your applications, and you're able to build Docker containers, okay? See another step, you need to push to a container repository, okay? Because you've built containers, right? You need to store these containers in a repository, okay? So all the containers that have been built will now be stored in a repository. And repository could be Docker Hub, right? But for organizations, I don't see them using Docker Hub. They want to use Nexus or ECR, that's Elastic Container Registry, right? To store their containers, okay? So this is a container repository, okay? So now let's trace and look at stage 7. What do we have here? So 7, we want to integrate and deploy Docker containers to K8s cluster. KTS here is Kubernetes, right? Kubernetes cluster. Okay, so you want to integrate Kubernetes with Jenkins so that you can deploy the Docker containers into a Kubernetes cluster. So let's look at my Kubernetes cluster. Let's see what we have in here. So within my Kubernetes cluster, I have the controller, right, which could also be called master, right? So I have the controller. So you see, I integrate Jenkins with this so that the Docker containers can be deployed to the Kubernetes cluster, right? Because when codes are written at this point, there will also be some Kubernetes manifest files, right? Written to set up certain things, right? Know, oh, how many worker nodes do we need to create, right? And all of those things. How do we get connection, right? Using the node port, because that is what the users will access, okay? Set up the node port, right? So all of these settings here are also written in a file, the manifest file. So the manifest file will be in here, right? It's part of the codes that were pulled, and that will be deployed, right? Because everything that has been set up, right, will now be deployed to the cluster, okay? So remember that we did a push of the Docker image, which went here. So this push, right, the worker nodes will now have to do a Docker pull from the registry so that the container can come here. So we can have Kubernetes doing container orchestration, okay? So once that is done, we'll realize that the deployment is completed and users can access what you have in the Kubernetes cluster using the node ports for connection, okay? So also every other thing we had before now, right, under monolithic architecture, we now stand, right? Just as we had under monolithic architecture, we have monitoring, analysis, feedback, and ticketing, and all of that. So we also have all of those steps here, okay? Monitoring, analysis of logs, and ticketing to get feedback back to the developers. Okay, so those are some of the tools we'll be covering in the course of this program. Now, there are also questions I've got regarding, oh, how does it work? How do we access the program? How do we pay for the program? So everything can be done right from our website. So let me go to the website. Okay, let me try a new browser. I close this. Okay, try a new browser. Try a new browser. Let's try this person. Okay, so let me see. So to access our program, can go to become a tech pro.ca.com. Become a techpro.com. So you go to the website, becomeatechpro.com. Just a minute. So you can check out the course gallery, look for the course you want to subscribe to. Just a minute. Look at the course you want to subscribe to. Just want to do it quick. Okay, so let's say I want to subscribe to DevOps Made Easy. I can go ahead and click on Get Course. Okay, so when I click on Get Course, it shows that I have not registered, right? It's possible that I already have a username, right? Or I don't, okay? So if I don't have a username, I can come in here and register, right? But in this case, I have a username. So let me just come on and enter my username. Let me enter my username. And my password. So I get access to the login area. Then I can click on Get Course. So click on Get Course. Close this. So I have just one item in my cart. Okay. So if I go to becomeatechpro.com, I believe there's a certain coupon code that I can apply. Let's see, it's going to come up soon. I can apply the coupon code here to get some discounts off this current price. So it should pop up soon. Pops up after about 1 minute. So it allows you to go through the website, see how it works. We have courses, what we offer. We offer a guaranteed full life cycles career support that covers immersive training, interview preparatory sessions, post-training development sessions, and on-the-job support / mentorship. Other features that make our program unequaled include live online sessions. Okay, so this is the code. Let me get it. Let me get the code. AVUV2. AVUV2. Okay, so that's the coupon code. Let me apply it. Okay, coupon code has been applied successfully. Okay, I'm able to get some discounts. Okay, so I can proceed to checkout. So once I'm here, I can look at my details. Okay, so there are 3 options I can choose. If I'm paying in full, I can enter my card details here, right? I enter my card details here. If I'm paying in full, that's one option. Okay, then if I'm paying via PayPal, I can select PayPal, which will give me 2 options as well. I can choose PayPal outrightly or paying with debit or credit card under PayPal. Okay, so these are the different options. Then if I want to pay in installments, I can select partially, right? Partially. Once you select partially, you can place your order, right? Then tells you how much you are paying today and how much you'll be paying for the next 5 months. Okay, so then if you want to choose your first payment date, okay, that's after today, the next payment. If you want to choose it, you select the appropriate date you want, okay? So you can change the date, then you click on proceed to checkout. So this is about it. If there are questions, please feel free to reach out on the platform. You can chat directly on here. You can chat directly here on the platform. You can chat directly. You can get my email address and our phone number. You can get it from here. And looking forward to seeing you in class on the 5th of November. So this is what we have. So, and if you, once you enroll in the course, you'll be able to, just a minute, let me go to, okay. Once you've enrolled in the course, you'll be able to see, to check in, to access the class, right? So, for example, once you complete your registration for the course, you'll be able to see, you'll be able to view videos relating to the courses and all of that. You'll be able to join the class here, and it will show you the dates, right, that the next class is going to hold with the countdown timer. Then you can check in with your enrollment email address to get access to your seat, right, for the next class. So that's about all. Look forward to seeing you in the next session. That's going to be on the 5th of November, 2022. Thank you, and bye for now.